Hi scholars, so today we're going to continue finding equivalent fractions, except today we're going to be using multiplication instead of visual models. Let's go over our vocabulary. Greater than, which is this symbol right here, is a symbol we use to compare two numbers when the first number is bigger or greater than the second number. Less than, which is this symbol here, is the opposite. We use it when the first number is smaller than or less than the second number. And equivalent fractions, equivalent just means equal. That's the math term for equal. Equivalent fractions are fractions that have the same value, that are equal to each other. 1/2, 2/4, 4/8, they're all equal. They take up the same amount of space in their fraction bars. So here I have 1/2. I'm going to multiply this 1/2 in order to find another fraction that is equal to it. Now, the only thing that I have to do, regardless, is always multiply by the same number. I'm going to multiply the numerator and the denominator by the same number. Now, the number that I use does not matter because I don't have a fraction here. I want to find that fraction. I personally like to use 2 because it's a very easy number, but really any number would work, and I'm going to prove that by using 3 instead. So if I multiply 1/2, the numerator and the denominator by 3, I'm making a new fraction that is also equal to 1/2 because I'm changing the numerator and the denominator. That's why it's important to do both, because if I only change one, then I'm going to have a completely new fraction that has nothing to do with the fraction that I just had. So 1/3, 1/2, 1 times 3 is 3 on top for my numerator, and 2 times 3 is 6 for my denominator. So now I have 3/6. I'm going to do it again using a different number. Say I did 4 instead, just to prove the fact that it'll still be equal. So 1 times 4 is 4, 2 times 4 is 8. So I have 4/8 and 3/6. Now these should both be equal to 1/2. So I'm going to prove that, or actually check my work using cross multiplication. So let's do 3/6 first. I'm going to cross multiply. 2 times 3 is 6. 6 times 1 is 6. So that's equal. Now let me test out 4/8 with 3/6, because if these are both equal to 1/2, then they should be equal to each other as well. So if this is true, then I know that my strategy worked. 8 times 3 and 6 times 4. Well, 8 times 3 is 24, and 6 times 4 is also 24. So I am in fact correct, right? So it doesn't matter what number you multiply by, it just has to be the same number for the numerator and the denominator. So go ahead and try this one. You can multiply the numerator and the denominator by any number you want, and then check your work by cross multiplying. So pause now, solve this one, and then check your work by cross multiplying. If you haven't already, please pause to solve and then press play when you're ready. So like I said, it doesn't matter what number you used. I'm going to use 2 because like I said, I like that number. But it doesn't matter what number you used. You can always check your work by cross multiplying. So I do 3 times 2 is 6, 4 times 2 is 8, I get 6/8. So I'm going to check my work by cross multiplying. 8 times 3 is 24. Look, I got the same fraction that I had before. And 4 times 6 is 24. So they're both 24, they're equal. Now, I used 2, but you could have used 3, 4, 5, any other number. So some other fractions that are also equal to 3/4 are 9/12, 12/16, 15/20, 18/24, right? So if you multiply by any other numbers, these are some other fractions you could have found. So any of these fractions are also correct. Just want you to know that, just in case you didn't use this specific fraction. So if you got any of these other fractions, you're not wrong. We just used a different number. And like I said, you can always check your work by cross multiplying. The only problem is the bigger the number you multiply by, the harder it is to cross multiply, because then you have to multiply by a bigger number. For example, let's say I did 12/16. I want to check my work. I then have to multiply by 2 really big numbers, 16 times 3 and 4 times 12. Those are big numbers. They both equal 48, and that's why I like to stick with multiplying by 2 or 3, because then the numbers that I have to cross multiply are still small. So what about this? I'm not picking any random fraction. I have a specific denominator that I'm trying to find. So I have 2/3 is equal to how many sixths? Well, I'm still going to multiply. I want to get from 3 to 6. So I'm going to multiply by 2, right? Because 3 times 2 is 6. So I have to do the same thing to my numerator. I can't leave this alone. So my answer is not going to be 2/6 because that means I wouldn't have changed my numerator. So 2 times 2 is 4. So 2/3 is actually equal to 4/6. I'm going to prove that by cross multiplying. 6 times 2 is 12, and 3 times 4 is 12. So I am in fact correct. So go ahead and try this one. Same idea, except instead of having a specific denominator, you have a specific numerator. So same thing, we want to figure out what number to multiply the 2 by, and then use that same number for the 5. So go ahead, pause now, solve this. 2/5 is equal to 4 what? If you haven't already, please pause the video to solve, and then press play when you're ready to go over your answer. So I had to multiply by 2, because 2 times 2 is 4, so I have to do the same thing to the bottom. 5 times 2 is 10, so 4/10 is my missing fraction, or equivalent fraction. And again, I check my work by cross multiplying, very important step. We always want to check our work as mathematicians. 10 times 2 is 20, and 5 times 4 is also 20, so I am in fact correct. Yes. So let's recap. What are the 2 ways we can find equivalent fractions? We can draw it out, make sure they're equal to each other, or we can multiply. Let's see, I have the same fraction, 2/3, 4/6. 2/3 times 2, the 3 and the 2 by 2 equals 4/6. Now once we have this equivalent fraction, how do we check our work to make sure we're correct? We cross multiply, right? 6 times 2 is 12, 3 times 4 is 12, so I know that these are in fact equivalent fractions. 2/3 is equal to 4/6. Thank you so much for watching. So we now have 2 strategies to use to find equivalent fractions, drawing it out and multiplying. Again, as always, you choose whichever strategy makes the most sense for you. You don't have to use both. But I do want you to cross multiply to check your work. All right, bye guys, thank you.